We are finally to the shapes that aren't parallelograms. Everything else we talked about quadrilaterals and all the different types of parallelograms. And these are quadrilaterals that aren't parallelograms. Trapezoids and kites. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called bases, and the non-parallel sides are called legs. Base HG here on this figure and base EF. And then the other two sides are called legs, and they are not necessarily congruent. But if you have a special trapezoid called an isosceles trapezoid, that is a trapezoid whose legs are congruent. So this is an example of an isosceles trapezoid. Those are the legs, and they are congruent. The other two sides are the parallel sides. And it says the diagonals of an isosceles trapezoid are congruent, and each pair of base angles are congruent. I'm going to try to mark that on this diagram, and it's going to get really busy. And I'll explain why. If we draw in this diagonal and the other diagonal, they intersect one another. The only way for us to indicate that they are congruent is to write it down and say it. Okay, diagonals are congruent. Or on the diagram, we can mark that this piece would be congruent to this piece, giving us a little baby isosceles triangle down there, which would mean this angle is congruent to this angle, because base angles of an isosceles triangle are congruent. To get the diagonals congruent, we would have to show that this piece and this piece were congruent. So I'm going to put 3 slashes on them, because if you add 2 congruent segments, you would get another bigger congruent segment by segment addition postulate. All right, now, I've got another triangle over here and here that are congruent. These angles up here are equal. So if I mark those with 2 arcs, those angles are congruent. And it says that each pair of base angles are congruent. Well, that's those entire angles up here, because this is a base and this is a base. I need to somehow show that this angle, I'm going to do 3 arcs, is congruent to this one over here. And then I'm kind of tired of I don't feel like doing 4 arcs down here on these guys. So I'm going to do an arc with a slash through it. That's a new marking. And those angles are congruent to one another. Now, it might be nice for you to draw yourself another trapezoid, and I get to cheat and use my little tool here. I'm just going to put another one over here. Excuse me. Oh my goodness, I never can sneeze just once, it seems. They usually come in 3s. Anyway, this is an isosceles trapezoid. And I thought it might be nice to show that the base angles are congruent on it. And here's what I'm talking about. That angle is congruent to this angle, and these two are congruent. That's what they mean by the base angles are congruent. Okay, what might be true also about the consecutive angles on the sides that aren't parallel, between those parallel sides? What do you think's going on with these angles? Angle H plus angle E. What do you think it adds up to? 180. Okay, remember, 2 parallel lines cut by a transversal gives you consecutive inferior angles are supplementary. Okay, so in this, you don't have to draw that. I just drew it to remind you of where we came from. So we also have angle H plus angle E is 180. Angle G plus angle F would equal 180. They are supplementary. All right, that's about all we need to say right now about those trapezoids. So let's flip over to the next, I see on your ISN right below there, and talk about medians. A median or mid-segment of a trapezoid is the segment that joins the midpoints of the legs. So that would indicate that this is a midpoint of that leg, and the trapezoid is just turned sideways. That would be a midpoint of the other leg. And the thing called the median is connecting those midpoints. Median or a mid-segment is another way to name it. So what's true about this? Well, the median is parallel to the bases. Okay, so it's parallel to those bases. And it is half the sum of the measures of the bases. Well, it's halfway between them. Okay, kind of makes sense that it's half the sum. But you add them, it's like you average those bases and you will get that median length. All right, we'll do that example in just a minute. Find the measure of each angle. Well, I mentioned to you a moment ago that if this is isosceles, because this is 5 and this is 5, that means this is an isosceles trapezoid. And that would mean the base angles are congruent. So angle K is congruent to what other angle? J. Okay, so these would both be 40. So the measure of angle J is 40. And now we want to find out what M and L are. I could give you several strategies in order to figure that out. What are the 4 angles add up to in a quadrilateral? 360. So you could do 360 minus 40 minus 40, which would leave you with 200 and what? 80? And then you'd have to share it between those two congruent angles. So if you do 280 divided by 2, you would get 140. Now, it's not the only way to get it. But I'm comfortable with you doing it that way, but I really would think it would be easier if you would realize that angles K and L are consecutive interior supplementary. So it would be faster to do 180 minus 40 and get 140. Don't you agree? 180 minus 40 would be a lot faster. So regardless, I would like you to remember that the angles of any four-sided figure add up to 360. However, these are supplementary, so it would be faster to do 180 minus 40 and get 140. All right, so the measure of angle L is 140, and the measure of angle M is also 140. Okay. Now we're going to talk about the mid-segment thing. So MN is a mid-segment, or a median, it says. ABCD is a trapezoid. It just says trapezoid, doesn't imply congruence. It says AB is 10. 10 would be a base, then. AB is a base. CD is a base. If you have two bases, then you take those bases and you add them. And then you divide that by 2 to get the mid-segment. So 10 plus 22 is 32. 32 divided by 2 gives me 16 for the median. Okay, what is the difference between 10 and 12? 10 and 22, and I just said the answer. 10 and 22. Difference? 12. What's half of 12? What's 10 plus 6? What's 16 plus 6? 22. So you can even think it out like that if you want. And I'm going to kind of use that, a little bit of a logic there on that for the next one. I'm going to show it algebraically and I'm going to show it intuitively. Okay, so AB is a base. MN is not a base. It is a median. We want to find a base. So if we were to follow the formula, we would have to do CD plus 18 divided by 2 equals the median 22. Well, that's CD. Okay, if you were to do that, you would need to multiply both sides by 2. That would give you C to D plus 18 equals 44. You would subtract 18 from both sides and get C to D is 26. Okay, now let's see if we can't do it another way. All right, AB is smaller than 22. The median is 22. That means that the other base is bigger. I hope that makes sense. If the median's in the middle, then AB being smaller than that would make the other one bigger than 22. So, what's the difference between 18 and 22? Okay, that's plus 4, right? So let's go up 4 more. And we get 26. So I've tried to give you options of how to think it out. Whatever is most comfortable for you is great, as long as you get it right, of course. We want it to get it right. So here's another way to think it out. AB and MN. It's just what I was doing up here. You could say 22 minus 18 equals 4, and then 22 plus 4 gave me 26. Okay, I found the difference between the smallest and the medium one, and then I added on that difference to the median to get the larger. Okay, so you can do the algebra way using the formula, or you can do a more intuitive way. It's also nice, I mean, when you have a picture and you draw it on there, if you went 18 and then you went 22 and then you went, what's this? And you could say, okay, that's up 4, up another 4, 26. So whatever works for you visually, algebraically, blah. Now let's talk about kites. And before we talk about kites, I want to do something. If you were asked as a child to make a kite, let's say you were in grade school and your teacher said, let's make some kites. What might you start with? If you're going to make a kite, you need a frame, right? What would you use for a frame? And I'm telling you, we're going to make this kite out of some fabric or some cardboard chunks and sticks. So what would you do? Okay, so I heard make a cross. So when you say make a cross, you mean that this is going to be longer than this, right? Okay. How would you set them together? I'm trying to teach you in a way that makes you think and know the properties before we even tell you what the properties of a kite are. How would you put those together? Say that again, Chloe. With string, or you would somehow glue this or tie it or whatever it is. But what would you make this be that you know geometry-wise? You would make them what? What kind of angles? You guys are mumbling, so I'm not hearing. Right angles. Okay, you would probably put those at a right angle, wouldn't you? Isn't it? You wouldn't want them to be crooked, and even though mine's slightly, because I probably should fix this a little bit. There, that's better. Okay, and then you would take and say you had to cut some cardboard out. How would you make the chunks? Okay, let's just say it this way. How would this compare to this? And I didn't make these perfect. And how would these compare if you made these chunks of cardboard and you attached them to your frame? What would be true of this and this? Congruent in what? Their measure, their length, or whatever. Okay, so this would be equal to this, wouldn't it? Okay, and this would be equal to this piece. See how you'd probably be thinking it out? And what about here? Are these equal, these pieces? Like that, you probably have to make sure this was the same size as that, right? And then your sticks were at a right angle. Well, we just figured out a ton of things about a kite. Okay, I hope it got some of you to see more about what's going to happen right now. A kite is a quadrilateral with exactly 2 pairs, and you maybe wouldn't word it this way, but they're called consecutive, which is one after the other, congruent sides, or congruent consecutive sides. Unlike a parallelogram, the opposite sides of a kite are not congruent or parallel. So in this kite, this side's congruent to this side. AD is congruent to AB. Okay, and BC is congruent to BC. I don't like how I made my slashes on that side. Fix those. Okay, so what it's the diagonals are, we said we'd put them at a right angle. So that means the diagonals are perpendicular. That's our vocab word for making a right angle. Only one diagonal is bisected. Which one was it? Doesn't have to be necessarily a short one, depends on how you draw the kite, but it would be that short one in this picture, right? BD is bisected, but not AC. Two sets of consecutive sides are congruent. We already marked those. Angles at the ends of the non-bisected diagonal are bisected. That would mean angle 1 is congruent to angle 2. And angle 3 and 4 are congruent, but they're not the same size as 1 and 2. Okay. Starting to look like a lot of marks on here mean a lot of things. We've got right triangles, congruent right triangles. And the angles at the ends of the diagonal that is bisected are congruent. Now they're talking about angle ADC and ABC. That's kind of awkward to see. So this picture, I'm thinking I'm going to add one in unless we've got another one coming up. You may wish to draw yourself a little kite. And all I'm going to fill in on it is what angles they're referring to. If this is A, B, C, and this side's A, B, C, they're talking about these angles being congruent. All right, now, up here, there's more stuff we could actually have marked. I'm going to put a little dot in the corner here on angle ADE and a dot on the other ABE because those angles are congruent. And then these angles are also congruent to one another. I'll just put 3 arcs on there. Okay, next. Oh, that was it. So I think that we've got everything we need to know. Oh, what does the long diagonal do to the kite as well? If you want to draw this, you can. The long diagonal cuts the kite in half into 2. Oh gosh, that's horrible. All right, anyway, all I want you to know is these 2 triangles are congruent on the left and the right. Okay, let's go to our worksheet packet that you picked up on counter. Oh, I just grabbed, boom, here we go. Trapezoids and kites again. All right, so we've talked about all of these quadrilaterals, and I actually filled in the whole board in the back. Did I miss something? Oh, I'm sorry. I will jump right back to it. I don't know why I did. That's why, because I put the blank page in there and I forgot there wasn't a blank page. We have more stuff. All right, sorry, let's do these. We absolutely want to do these. Sorry about that. Note the kite has a line of symmetry. That's when I last drew. The diagonal that is not bisected is the line of symmetry. In this example, AC down here is a line of symmetry. Cuts that whole thing in half. All right, it says WXYZ is a kite. Find the measure of angle Z. Well, angle X and angle Z are congruent. Okay. You've got an 80-degree angle and a 60-degree angle. A kite has 4 sides. The sum of the angles would be 180 times 4 minus 2, and that's 180 times 2, which is 360 degrees. So, what do all those angles add up to? They add up to 360. Not 180. Everything isn't 180. So what size are X and Z? Well, let's take that 360 and subtract 80 and 60 and see what we have left to share between X and Y. That's 140, that's 220 degrees is what we got after we subtracted, right? Well, we got to divide that by 2 because angle X and Z can't possibly be 220, and you need to split it into those two angles. So we divide that by 2 and get 110 apiece. All right, so those would be 110 each. If ABCD is a kite, find BC, it says. Well, we know the diagonals of a kite are perpendicular. We want to find B to C. So what I'm trying to hint at is to look at this triangle right here. If you like to use highlighters, I'm highlighting it. And that's what I'm going to be looking at, is that right triangle there. What I'm going to use then is something that we've talked about in the past, and you may want to write it down again. If you have a triangle, the legs are A and B, the hypotenuse is C, and A squared plus B squared equals C squared. So we're going to use the fact that the legs are 5 and 12 and write an equation. 5 squared plus 12 squared equals the side BC. I'm going to put an X on it just for simplicity's sake. Equals X squared. So then I get 25 plus 144. You just type that part on your calculator. You get 169 equals X squared. You take the square root of 169 to get X. Or to take the square root of both sides is what you're technically doing. And you should get 13. Okay. Anybody still need this? No. All right. That was finally the end. And now we'll go to the packet that I jumped the gun on. We have talked about all of the properties of all of these shapes, all of the quadrilaterals. Parallelogram, rectangles, rhombus, or rhombi, squares. Trapezoid, isosceles trapezoid, and a kite. We already found out that the diagonals of an isosceles trapezoid are congruent. This one is your isosceles one. And if each pair of base angles are congruent. Now, it has exactly one pair of parallel sides. This is just the bases and the legs. We've already discussed those, so I don't want to waste more time just labeling everything. But if the diagonals are congruent and the base angles are congruent, I can mark those base angles. And then I'm thinking I would rather have another trapezoid in order to show that the diagonals are congruent. Okay, so I drew another one. I probably should add another one to your notes. And I drew in the diagonals. I'll still show it's isosceles. And then I would have to mark these two segments congruent and these two segments congruent separately. And if I called this ABCD, AC is congruent to BD. All right. Can I go? All right. The median, again, we already discussed to do base plus base divided by 2. That will equal the median. That's a formula. So let's do some samples. We've got V and U. How do you think those are related? What might be true? This side's parallel to this side. These are cut by a transversal, And these are on the same side, and they're one after the other, which is consecutive interior. So they add up to 180. 21x plus 6 plus 90 equals 180. Now, if anybody wanted to realize that if they do, and that's 90, that this angle also has to be 90, you could do 21x plus 6 equals 90, right? Not the only way to get this done, but I'm going to remind you they're supplementary. All right, so 21x plus 96 equals 180, and then you would subtract 96 from both sides, giving you 21x equals 84. Divide by 21, and you get x is 4. And it only asks us to find x. All right, so what's our equation for number 2? The same exact idea. Those two add up to 180. Okay. All right, so I got 12x plus, what's 55 plus 17? 72 equals 180. Subtract 72. All I did was combine my numbers. Subtracting 72, I got 12x equals 108. Oops. And 108 divided by 12 gives us x is 9. Yes. All right. Oh, sure. All right. Oops, yeah, I went the wrong back. Did you get what you needed? You needed this. Was that all set? All right, ABCD is an isosceles trapezoid. Okay, so all the problems ahead are isosceles trapezoids. Okay, what that means then is that the sides are congruent, the ones that are not parallel. Now this says AB is 30. AB is the top, that's the base. CD is 42, that's a base. And then we found out that to find the MN, the median, you do base plus base divided by 2. First, you got to add those bases, and then you'll get your median. All right, so instead of writing on this, because these are going to change numbers over and over, I'm just doing the formula for this one. So it's going to be 30 plus 42 divided by 2. That's 72 divided by 2, so the answer to MN for this one is 36. All right, now, the next one, you got AB's 18, MN's 25. So how far did you go to get from 18 to 25? Yeah, you can do 25 minus 18, which is adding on 7. So if you add another 7 to the 25, you get 32. A lot easier than doing the formula, right? Does anybody want me to show it with the formula? Yes? Okay. With the formula, you would take 18 plus CD divided by 2. That would need to equal 25. You would multiply both sides by 2. That would give you 18 plus C to D equals 50. And then you would subtract 18 and get your 32. That always works. We have to do number 5 like that because we've got a bunch of x's and stuff. So AB is a base, MN is a median, CD is a base. We have to do base plus base divided by 2 equals median. 6x minus 3 plus 8x plus 5. All that is added up and then divided by 2 equals 15. Okay, got to do this one this way. So I'm going to add my 6x and 8x. That's 14x. Minus 3 plus 5, or 5 minus 3 is 2. And then I still got divided by 2 on the bottom. So I want to get rid of division of 2, so I'm going to multiply by 2. I end up with now 14x plus 2 equals 30. And then I keep going, subtract 2. 14x is 28, and divide by 14. So I get x is 2. Now, that's not all they wanted. They said, what's x? Well, we got x is 2. Then it wants AB. We'd have to plug 2 back in. 6 times 2 minus 3 is 12 minus 3, and that's 9. And CD, 8 times 2 plus 5 would be 16 plus 5, and that's 21. Oof, a lot of work. Okay, so you'd have 3 answers, 2 for X, AB is 9, CD is 21. My D's are looking like O's or something. All right, now we got angle measures. Angle 1, angle 2. Well, we already know the base angles. This is still an isosceles trapezoid. So the base angles are congruent. What do you think angle 1 and 2, how do you think they relate? Well, we got parallel lines, guys, transversal. These are corresponding. Those are equal to them. Corresponding angles are congruent. Measure of angle 1 is 4x minus 60. If all of those angles are equal, then angle 1 and angle C are the same size. Measure of angle 1 equals the measure of angle C. So we're going to pop in the algebra. 4x minus 60 equals 30 minus x. I would need to add x. I get 5 times x minus 60 equals 30. Add 60. 5 times x is 90, and divide by 5. So I get x is 18, and then I need to find the measure of angle 1 and the measure of angle C, which are the same number. 30 minus 18 is only 12. 12 degrees. This is definitely not scale. This would be one pointy looking trapezoid. And angle 1 is also 12 degrees if you plug in. 4 times 18 minus 60. Okay. 7. Now it says angle B and angle D. Well, angle D and C are congruent, but angle B and D aren't. What's the relationship between angles B and C? They're supplementary, okay? So angle B plus angle C is 180. And I can say angle D and C are congruent. So if I do a substitution, angle B plus angle D equals 180. Agreed? Because D and C are congruent. So then I could say, all right, then I can just do 4x plus 40 plus 3x is 180. Combine my like terms and get 7x plus 40 equals 180. And I subtract 40. I get 7 times x is 140. And then divide by 7 to get 20 for x. So then it wants us to find the measure of angle B and the measure of angle D. Well, B would be 4 times 20 plus 40, and that's 80 plus 40, 120. And the other one is 3 times 20, so it'd be 60. Bless you. How are we feeling on that? Any questions about this one? All right, try another. Oh, looks like we're back to the mid-segment stuff. FE is a base. V to Y is a median. Find the base, CD. Well, from 18 to 28 is adding 10. So if we add 10, we end up with CD is, 38. Is anybody confused about that method or what I did to get that? All right. Angle F is 140. I'm going to put on my picture. That would make angle C, well, it didn't ask me for angle C. That would make angle C 40 and angle V 40. But it says something else. It says angle E is 125. Find angle D. Well, how am I going to get angle D? I don't need that 140 or those 40s. They aren't going to help me at all. I need to look over here. These are supplementary. So I need to do 180 minus 125. And that gives me the measure of angle D is 100, no, not 100, it'd be 55, right? Okay. The 140 would have been to help us find other angles, not the one we needed. Okay. A kite's a quadrilateral with exactly two pairs of consecutive sides congruent. Unlike a parallelogram, the opposite sides are not congruent or parallel. We already discussed all these properties in our ISN. One thing to note is here that this angle is congruent to this angle. You could also say angle 1 and 2 are congruent on that diagram and that these are congruent. We know about the consecutive sides and the parallel, perpendicular symbol is already showing that we have right angles in the center here by E. All right, let's just move on to just a few problems. Let's find the measure of angle JRK. JRK. That's right here. How big is it? All right, 90 degrees. Diagonals are perpendicular in a kite. Then it says if J to R to J is 3, and R to K is 10, R to K, okay, all the way here. What's J to K? And I'm not just kidding. I want you to find it. So we got a right triangle over here. Ha, ha, ha. Okay, and that's 3. This is 10, and we want to find x. We're going to use the Pythagorean theorem. The x is on the hypotenuse, so we go 3 squared plus 10 squared equals x squared. It's 109. And then we take the square root of it to find our x value. So C to D is the square root of 109, which is about 10 point something. Help? Y'all have calculators? Thank you. I appreciate it. 10.44. All right. You're going to need to be able to use Pythagorean theorem on some of these problems, clearly. Okay, measure of angle GHJ is 90. GHJ, oh, this picture makes me crazy. It is so not to scale for this question. All right, GHJ. They're telling us that tippy top part is 90. Okay, and then I can't mark it on there. It's just kind of a pain to do. And then they're trying to tell us that down here where the K is, GKJ is 110. Okay? I got a couple of ways I could do this problem, but the easiest way is to remember that angle G and D, or J, and I can't name it that when I look at that diagram because there's more little angles there. But looking across here, those are equal. So the angles all add up to 360 on a four-sided figure. So I'm going to do 360 minus 110 minus 90 and see what I've got left for those two angles. Someone tell me what 360 minus 110 minus 90 was. 200. 160, right? Okay. So that's telling me that I have to share that between two angles. Okay, so I'd have to divide this by 2 and get 80. GH. They're saying find GHK. Where is that? Oh, why did I do all that work? GHJ is 90, so what's GHK? If that's 90, then this would be 45. HC. Oh, no, I found the right angle then. HCK. I found the right angle. I was like thinking I didn't. I don't know what happened to my brain right there. Okay, so we are running close to time. I do think you only have one more example before your homework. You need to work on this. And I'll let you know that tomorrow we're going to do a quick review and we have a short quiz on the shapes we've talked about before today. It's a short quiz naming them, and you get to use your ISM.